All right, we're going to look at a motion problem. We're going to look at a lot of different things that we can determine about the motion of an object. So this one is going to be an object that is moving left and right, and here is our position function. Some of the things that we're going to look at is when is it moving left, right, and stopped? When is it speeding up? When is it slowing down? We'll follow the motion of the object and go from there. Okay, so the first thing we want to do is find the velocity function, which is the derivative of position, and that would be 3t squared minus 12t plus 9. Next, we want to find the acceleration, and the second derivative of position, which is the first derivative of velocity, is our acceleration function, which is 6t minus 12. So we have a position, a velocity, and an acceleration function. So to determine when the object is moving left, right, or stopped, we need to look at values of the velocity. So we'll start by taking the velocity and setting it equal to 0. So we have 3t squared minus 12t plus 9 equals 0. I'll divide each term by 3. Simplify this a little bit more. This will make the factoring easier. And we factor to t minus 1 and t minus 3. So the velocity is equal to 0 at 1 and 3, which we know that is when the object is stopped. One thing I did leave off is that this particular one, the function is defined only for values 0 or greater. Okay, so our acceleration function, the derivative of velocity, which is acceleration, we're going to set that equal to 0. So 6t minus 12 equals 0. 6t equals 12. T equals 2. All right, from here, I'm going to create an interval chart. And for our interval times, we're going to have 1, 2, and 3 when either the velocity or the acceleration is equal to 0. We're going to go from 0 to infinity. So we start with 0 is less than or equal to t is less than 1, because that's the first time when something happens. Then we have at 1, and then we have between 1 and 2. Then we have at 2, between 2 and 3. We have at 3, and then when we are greater than 3. So over here, we're going to have our velocity, our acceleration, and then we'll write some conclusions. Okay, so for our velocity, again, we're only concerned with, let me lock in that, there we go, the sign, whether it's positive or negative. Remember, if velocity is negative, then we know the object is moving to the left. If velocity is positive, it's moving to the right. If velocity is 0, the object is stopped. So we know that it is stopped at 1 and 3. So at 1 and 3, I'm going to put 0. For values less than 1, say if I plugged in 1/2, if I plugged in 1/2, this factor would be negative, that factor would be negative, the product would be positive. Between 1 and 3, if I plug in 2, this factor is positive, that factor is negative. So for all values, we know the velocity is negative. For anything greater than 3, so if I substitute 4 for t, we get a positive value. One other way to look at finding the values, we do know that we have a parabola with zeros at 1 and 3, a y-intercept of 9. It is face up because a is 1. All of that stuff we get back from our Algebra 1 and Algebra 2 days. And so in general, the velocity graph, right, would look like that. And so we're positive, 0, negative, 0, positive, exactly what we have here. So our conclusions, object is moving right, stopped, left, stopped, right. So we're moving right, stopped, moving left, moving left, moving left, stopped, and moving right. Okay, our acceleration, we have 6t minus 12. We know that at 2, the acceleration is 0. For values less than 2, such as 1, I'd get 6 minus 12, which would be negative. So we know that we're negative. For any value greater than 2, like 3, we'd get 18 minus 12, or 6. So that would be positive. Again, we have a linear function for our acceleration. So just from a graphical perspective, right, there's negative 12, there's 2, and there's our acceleration graph, right? And we're negative, 0, positive, just as we have here. So now the conclusion that we're going to make is comparing the two. So look at it this way. Let's say this was vertical motion. The velocity of the object in this time interval is positive, which means the object is going up. The acceleration is negative. Something that would be gravity. So that means that the gravity, the acceleration, is pulling the object down. So if an object is going up, like say you throw a ball in the air, as it goes up, it is slowing down until it hits its apex, and then it would come back down again. So we know the object here is slowing down. And in general, anytime the velocity and the acceleration are opposite in sign, an object is slowing down. Here in this time interval, they are the same sign. So the velocity is negative, the object is coming down. The acceleration is negative, so the object is being pulled in the same direction. So the object here is speeding up. Again here, opposite in sign. So the object is slowing down. Here in this time interval, same sign. So the object is speeding up. Okay, if we wanted to follow the motion of the object on a number line, we could do that right here. And so this represents the position function. And then we're going to put some positions. So what we're going to do is find the position here at 0. So S of 0 is 0. So here's the position. And we start there at time t equals 0. We know we're moving to the right until we get to 1. And we're going to substitute 1 into our position function. 1 minus 6 plus 9. That's going to be 4. So 1, 2, 3, 4. So we're moving to the right until we get to 4. And then it's going to stop. And we know it's going to turn, and we know it's going to come back left. And again, it stops at time 3. So we're going to substitute 3 into here. And as it turns out, it coincidentally, it comes back to 0. And it's going to stop. So this was t equals 1. This is t equals 3. And it's going to turn around again and go to the right. And if we substitute any number greater than 3, we're going to end up with a position greater than 0. So here we are going right, stopped, left, stopped, right. So there's a lot going on there in terms of from our position to our velocity to our acceleration, and then looking at the sign of velocity, sign of acceleration to determine direction, and then determining whether something is speeding up or slowing down. So one other thing we can do is we can look at all of these on a set of coordinate axes. We can compare the three functions. So here we have our position function, and looking at some of our times before in terms of position, right? At 0, we were at 0. At 1, we were at position 4. At 3, we were back at 0, and then at 4, it went back to the right. So, right, there would be our S of t. Our velocity, which I have up here in green, we know the velocity, again, here's our velocity function. So at 0, we're at 9. we know that at 1 and at 3, we were at 0. And if we wanted to find out at 2, I believe we'd be at -3. So following along, there's our velocity. And finally, looking at acceleration, a y-intercept of -12, so 8, 9, 10, 11, 12. We have a at 0, or 2 rather, it equals 0. And so here, so that is acceleration. And then the green here was velocity. So remember, when we looked at this before, right, time intervals, speeding up, slowing down, moving right and left. Here, when we look at this graph, right, velocity from 0 to 1 is moving to the right because it is positive. Notice that the velocity is positive, but the acceleration is negative, right, all the way up here until 1. And so in this time interval, the object would be slowing down because the velocity and acceleration were opposite in sign, which is what we found here. Now, between 1 and 2, both velocity and acceleration are negative. So object is speeding up. From 2 to 3, we are opposite in sign, right? From 2 to 3, velocity negative, acceleration positive. So the object is slowing down. And then from 3 on, they're both positive. So the object is speeding up. And again, if you follow along the position, this would be moving to the right. Velocity is positive. Okay, then the object stops, turns to go to the left when velocity is negative, stops, goes back to the right as velocity becomes positive again. So again, a lot of ways to be able to determine some of this information in terms of following along as the particle is moving left, right, or up and down, stopping, and then speeding up and slowing down. So hope all of that helps, and we'll see you soon.